Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Okay, now we are looking at this case, which involves change in direction. It says that a cricket ball of mass 110 grams approaches the bat at constant velocity of 35 meters per second. The ball strikes the bat and undergoes change in momentum of 6 kilograms per second in opposite direction. Okay. Then the question says, calculate the final velocity of the ball. Okay, here, where do we start from? Well, we know our equation is delta P equals to mvf minus mvi. Okay, let us look at now these entities. Okay, what is the change in momentum? We have it there. So change in momentum is 6 kilogram meters per second. But you have to remember something. They said opposite direction. So it is what? Negative. On assumption that our initial velocity is positive. Okay. Then what else do we know? We know mass of the ball. The mass is 110 grams, non-SI units. So what do? We change it to kilograms by dividing with 1000. And you get 0.11 kilograms. Okay. What else do we know? We know the initial velocity, and it is 35 meters per second. Okay. So the question looks for the final velocity. So what do we do here? What we do is to substitute. So what do we substitute for delta P, which is minus 6. The mass is known and is 0.11. The final velocity is wanted. Then the mass is the same. And the initial velocity is 35. So when you look at this case, the only unknown is VF. So let us look at for these values. So this is what we get after simplifying. So what do? We collect like terms now. So we are going to have negative 6 plus 3.85 giving you 0.11 VF. And from there, if you can use this space, so there we are. We have negative 2.15 equals to 0.11 VF. So how do you get VF? You divide both sides by 0.11. So you're going to get our VF as negative 2.15 over 0.11. What you get here is going to be our final velocity of the ball. So that is what we get. The final velocity of the cricket ball is negative 19.55 meters per second. So what does the negative imply? Negative means opposite direction to the initial direction, to the initial one. So we are going to say equals to 19.55 meters per second, opposite direction. Opposite direction, or opposite to the initial direction. Yeah, then comes this question. It says, draw a vector diagram showing the final momentum, initial momentum, and change in momentum. So here, where do we start from? You start from our equation, which is delta P equals to mvf minus mvi. Okay, then you have to look for these values. What do you have as delta P? It is 6, but it was negative. Yeah, for PF, what do you have? We know mass, which is 0.11, and we found our final velocity as negative 19.55. Okay, then you proceed and find our mvi, where this one is going to be 0.11, and our initial velocity was 35. So from here, you look at for these values. We know this one is minus 6. We have to look for this, and we look for this. This one is our PF. Let's look for it. So here we are. We have our delta P. We have our PF and PI. So which one is the biggest? The biggest is our delta P. Okay. And these two are going to come and fit in that space. Now I want you to know that normally I'm right-handed, and I normally take right as positive. So if that is the case, this is going to be my delta P. What else do I know? I know PF is also negative. So I draw it there. What else do I know? I know PI. PI is positive. And there we are. What I'm having here is the vector diagram of representing change in direction. And with that, we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. Don't forget to subscribe. Don't forget to like, comment, to refer the channel to a friend. See you next time. We believe you will not regret. We are simply the best. Bye-bye.